Hey everybody, welcome to the 5 guided examples to go with the lesson on angle sum and difference identities. So to get this started, I'm going to pick up where we left off. I hope you were able to finish this on your own. Pi over 6 plus pi over 4, we have two radian angles we're trying to add together and they needed a common denominator. For pi over 6, you should have rewritten that as 2 pi over 12. Pi over 4 is 3 pi over 12. Their sum, when you add them, will be 5 pi over 12. If you got that, go you. Here, same idea. Well, that's pi over 4. We made it 3 pi over 12, so I guess I could put that everywhere I have a pi over 4. Nice. Pi over 3, I'd multiply top and bottom by 4, so that's 4 pi over 12. Pi over 6 was over there, 2 pi over 12. Let's just fill in everything we got. All right, there we go. The sum right here, 3 pi over 12 and 4 pi over 12 gives us 7 pi over 12. Pi over 4 minus pi over 6. Some people may not need to see this step and they'll just tell you that's pi over 12. They'll do that in their heads. That's the power of memorizing. But so here's the thing. The less you memorize, the more stuff you have to keep in your working memory at all times, and the harder math will get. The more stuff you memorize, you're putting that back into storage in your long-term memory. The more room you have in your working memory, and the easier it will be to solve a problem that's in front of you. Trust me, okay? That's why I like it when you guys memorize stuff. And this one over here as well, pi over 3 minus pi over 4, that's also pi over 12. So I hope you got all those correct. Now we had the angle sum and difference identities. We talked about alpha and beta, and we wrote down these bad boys over here. And now we're gonna apply these to a bunch of different examples. So after the warm up, here we go. Guided example 1. Find the exact value of cosine 75 degrees. If you need to find the exact value of something, that means no calculator. I know you might think it means calculator time. It actually means no calculator. A calculator will round for you, or you'll also round when you get an answer off the calculator because there'll be some big gross decimal and irrational number. And as soon as you round, you're approximating. An exact value will have the radical still in the answer, or will have pi still in the answer. That's more precise because the radical or pi or e, Euler's number, represent these irrational numbers in their entirety. So we prefer them that way. Cosine 75 degrees. Now, remember, these are guided examples that go with the lesson that we're doing. Don't act helpless. Don't act like you can never do this on your own. You use what we were introducing to do the examples that come after it. That's how school usually works. Fun fact. So we introduced you, me, my dog, I don't know, to this right over here, cosine alpha plus minus beta. I have this over here. I'm going to write this down. Get it on the paper. Do something. Don't do nothing, okay? Don't mess up the signs in there. So leaving a little room above it, but cosine alpha plus minus beta equals cosine alpha, cosine beta minus plus sine alpha, sine beta. So really above it, I need to take this cosine of 75 degrees and I need to write it as a sum or difference. And I need to remember I am not allowed to use a calculator. Usually when I'm asked to do the cosine or the sine or the tangent of something, it's an angle on the unit circle. It's a special angle or a multiple of the special angles. So multiples of 30 and multiples of 45 degrees. I have 75 degrees here. However, I do see that this does have something in common with those angles that are on the unit circle. It looks like I could rewrite 75 as 30 degrees plus 45 degrees. Slow down, pay attention, think about this. So that means you're going to let alpha equal 30 degrees and let beta equal 45 degrees. So that's the first thing we're going to do to get this started. We are writing a let statement. We are making some designations, or we're assigning a value to my alpha and my beta. Now, next thing, you never, ever, ever, do not ever say that you're going to distribute cosine. You will make your teacher cry. Do not do that. You don't do that. That's not a thing. No one says that. That's not a thing. You made that up. Don't make that up. Don't lie. You're lying. Okay? We have an identity. Alpha and beta. That's what I'm looking for. The cosine of 30 plus 45. Don't add it and make it 75 again. Dude, that's what we had. We're breaking it down so we could apply this identity. And now, everywhere you have an alpha, you're going to fill in 30 degrees. And everywhere you have a beta, you're going to fill in 45 degrees. It's like f of x equals, and you have an equation. And then you have f of 2. Everywhere you had an x, you fill in a 2. Same idea. All right, so down here, cosine of 30 degrees, cosine of 45 degrees, minus, okay, this was plus, plus goes with minus, so this is going to be minus, okay, just with cosine. Sine 30, sine 45. Guess what? We can do this now, thinking of it as it relates to the unit circle. 30 degrees is this angle over here, also known as pi over 6. We go over a lot. We go up a little. Cosine is your x value. Sine is your y value. We're going to get fractions all around, fractions for everyone. I hope you still know those values, and if not, you got to work on that long-term memory, okay? You have to memorize things that you can pull them back. You can't just keep it in your short term. That's when you only know it for a couple days, and then you have to keep reworking it in when you're applying it. Not good. Not good. Cosine of 30 over a lot. That's root 3 over 2. Cosine of 45. That's over medium and then up medium. That one was root 2 over 2. And if you don't know what I'm talking about by a lot, medium, a little, you have to go back to the videos that I have about the unit circle, evaluating trig functions. And I give you my whole little story there. Sine of 30, up a little, positive half. Sine of 45, up medium, root 2 over 2. Now, some of you may be rusty with your rules for multiplying, for dividing, for adding, subtracting, whatever, and fractions and radicals. So buckle up. Radical 3 and radical 2, they're both under square roots. So you can multiply and you get root 6. 2 over 2. I'm sorry, 2 underneath and 2 underneath, that's your common denominator. If you were adding or subtracting, that 2 would just stay as a 2. But when you multiply, you actually multiply. So we get 4. Minus 1 times radical 2 is radical 2. Sorry, someone's having a good day outside. It's nice, huh? 2 times 2 is 4. And then for the final answer, I'd probably write it as a full collected thought. Cosine of 75 degrees. Definitely rewrite the question at the end. It's a good idea. Equals, and then they already have a common denominator, so let's just write it all packaged together. Radical 6 minus radical 2 all over 4. You cannot combine radical 6 and radical 2. They're not like radicals. If you had like 6 root 3 minus 2 root 3, you would get 4 root 3. Like, that's okay. Not in this case. So that's it. We're done. That is the exact answer. It's precise. It's an irrational number. We have 2 radicals in there. And if you put that in the calculator, it would round. So to check this ever, if you want to check if you're right, you put cosine 75. Make sure your calculator's in degrees first in the calculator. Look at that decimal. Then you type this in your calculator. Make sure you use parentheses around the whole numerator. Be careful. And you say to yourself, well, is that decimal and that decimal, do they look the same? And if they do, go you. And if not, rewind, fix. Let's figure out where you went wrong. Okay? That's the end of it, guided example 1. And then you're going to have homework example or on your own example 1 as well. And you're going to have to do something just like this, but to a different problem. So to get this started, though, keep in mind as well, we use degrees. I chose that intentionally because I do think It's a little bit easier for you to wrap your head around degrees, but as you know, you mainly work with radians. So example 2 is going to show us some radians. Let's look at that. Guided example 2. Find the exact value of tangent pi over 12. Now just a bit ago, we did some work. That was on purpose. Pi over 12. We got it right over here. Let's use this one. Here's pi over 12. I could write it as the difference of pi over 4 and pi over 6. So there's my let statement, alpha and beta, all right? Because that's the same as alpha, same as beta. And when we subtract them, we get this guy. That's what we want to be working with, okay? So hold on to your butts. Let's go. Tan of pi over 12 equals tan. I'm just writing a few things down. Which one did I want to use? Pi over 4 minus pi over 6, which is the same as tan of 3 pi over 12 minus 2 pi over 12. All the same. So let alpha equal pi over 4, and don't use a plus sign for your and in math class. Beta equal pi over 6. All right. Now, that's subtraction. So I'm going to use tan of alpha minus beta. I want that identity. That was the last one written on the notes page. So tan alpha minus tan beta over 1 plus tan of over 1 plus tan of alpha tan beta. So here they're being multiplied, here they're subtracted. So we're set up, ready to go. Now everywhere we have an alpha, we're filling in pi over 4, and everywhere we have a beta, we're going to fill in pi over 6. Tan pi over 4 minus pi over 6 equals tan pi over 4 minus tan pi over 6 over 1 plus tan pi over 4 tan pi over 6. Now here's the thing with tan. You might end up having to clean up quite a bit of this and rationalizing or something along those lines. So leave yourself enough space. Don't squash everything. You're going to regret it. So careful, okay? Now, nice and easy. What I'm going to do is I'm going to do a little bit more here, and I'll move down to the next line. But like I said, I want to save space. Tan of pi over 4 is 1. If you don't know these quickly, you got to do some work, okay? Minus tan of pi over 6, and that is root 3 over 3. And here we have 1 plus 1 times root 3 over 3. Obviously, I don't really need the 1 times, right? Like, a little silly, so adios. Now, first beef I have with the problem. It's like inception of fractions, right? We have a giant fraction, and then we have fractions inside our fraction. Maybe you're not a fan. I don't blame you. We're going to multiply the whole entire top and the whole entire bottom, the numerator and denominator, by 3, and watch what happens. Times 3 times 3. Just rewriting it over here. Tan of pi over 4 minus pi over 6 equals, now, distribute that 3 to everybody. We're multiplying by 3 over 3, so that's 1 multiplicative identity. You're allowed, but make sure you distribute it to everybody. Top, we get 1 times 3, that's 3. Minus, do not write 3 root 3 over 3. Think with your brain. What's that? Just root 3, okay? Bottom, 3 plus, think about it, root 3. If you don't understand, do not be sad and copy it and just like let it be. Rewind, go back, think about it again, okay? Go, do it if you're confused. Now we're still not done. We are not allowed to keep a radical in the denominator. If you are an amazing notebook keeper, I want you to think way back to lesson 1, first day of school this year. And in lesson 1, we did a review lesson on simplifying radicals. And one of the examples, 5th, 6th, or 7th one, we had an example similar to this, where we had a sum or a difference with a radical in our denominator. And in order to rationalize that denominator, we had to multiply the numerator and denominator, don't mind the giant multiplication, by the conjugate of this guy right here. We want to multiply by the conjugate, and good things will happen. 3 minus root 3. Same thing on top and bottom. We treat them the same, but when we multiply, say a binomial or a sum or a difference by another sum or a difference, you have to distribute, and you can use FOIL to help you distribute. First times first, on top we get 9. Outer, I get minus 3 root 3. Inner, I get it again, minus 3 root 3. Last times last, root 3 times root 3 is root 3 squared. Square root squared. Think about it. You could either write root 9 first. Please don't do that though. Please don't. Or you could just go right to 3. Square root of 9 is 3, or root 3 squared. The square root and the square are inverse operations. So negative times negative is plus 3. Bottom is very similar, denominator. But first times first is still 9. Outer and inner are 3 root 3 and 3 root 3, but one's positive and one's negative. So what happens? They're gone. No radicals, yay. And then root 3 times root 3. It's going to be minus 3 though, because we have a negative and a positive. Now I'm going to clean up. 9 and 3. Minus 3 root 3 minus 3 root 3 is minus 6 root 3. 9 minus 3 is 6. We're going to use our pretzel. Beautiful. Final answer. The tan. I'm going to write down the original problem, okay? Of pi over 12 equals 12 over 6 is 2 minus 6 and 6 reduce, so that's a 1, but I'm not going to write the 1. Root 3. And there we go. Winner, winner, chicken dinner. If you want to check this in the calculator, again, you're going to go a little parenthesis heavy, at least, over maybe here. You're going to change the mode of your calculator from degrees to radians if you check the last one. So make sure you check that out. And you're going to have to look back at this example, I promise you. So bookmark it, something, put a note. You will come back, or you're going to try to ask me, like, how do I do this? It's going to be just like this. I do have some tips so you could avoid some of the simplifying, but we're going to have to wait and talk about that later. For now, we're just going to let you proceed. Number 2 on your own examples is just like guided example 2, so keep that in mind, okay? Let's look at guided example 3. Guided example 3. Find the sign of u minus v. So here I'm not using Greek letters. I'm just using 2 other letters. They tend to use u and v quite a bit. Not a big deal. Given that a sine of u is negative 3 over 5, with u, angle u, it's an angle, being between pi and 3 pi over 2. And then the cosine of v, so here we have this information given, and then we're given this, and cosine of v is 12 over 13, where v is between 0 and pi over 2. Now it's possible that they're both in the same quadrant of space. That's possible. That could definitely happen. So no matter what, when you're going to start off by drawing. We're going to draw a little bit of a sketch, a picture, diagram, whatever you want to call it, to help us. But you should draw them both on their separate planes, on their own unit circles, if you will, okay? So I'm just going to color coordinate a bit over here. Sorry, I have whiteout in there so you can kind of see it when I highlight. Okay, this one's a little intense. You got this. that's what I'm looking for, but let's just draw these out. Sine of theta, I'm going to write a little note, is opposite over hypotenuse. Try to space things out kind of the way I'm doing it. Pi and 3 pi over 2. Well, this is pi, and this is 3 pi over 2. So I'm really concerned with this space. So I'm going to draw a reference triangle. I know, throwback, like lessons 7 and 8 for this past year. There we go. That means U is really that whole thing, maybe. Or maybe it's that way, maybe it's more than once, whatever. But we're going to use the U over here as the reference angle and go from there. Sine of U, remember it's opposite over hypotenuse, is negative 3 over 5. The hypotenuse will never be negative, so we would always give it to the other side or leg of the triangle. So negative 3 is my opposite, right there. Over 5 is my hypotenuse. What else did we do? Well, back in lesson 6, we memorized the Pythagorean triples. Do you remember them? You're welcome if you did. Yes, it's 4, but you should be writing negative 4 because it's left, okay? Negative 4, negative 3, right angle. We're using a little reference U. 4 and U look a little like, sorry, there they are. Got my triangle. I'm going to use that. That's important. Now, and I'll color that orange in a second. Cosine, though. Cosine of an angle is adjacent over hypotenuse. All right, we're going to draw some stuff for cosine now. This one's between 0 and pi over 2. That's over here in quadrant 1. I'm going to draw my reference triangle. And I'm using angle V, so I can use it right there. It's in quadrant 1. It's already acute if I, drew it coming from that way. And adjacent over hypotenuse. So my adjacent is 12. My hypotenuse is 13. Another Pythagorean triple. They will not always be Pythagorean triples. You're going to have to do Pythagorean theorem, and you might get a radical. It's okay. You're going to simplify. Just hold your horses. Don't freak out. But if you remember what this is, amazing. It's 5, and it's positive because it went up. Now, what are we going to do from here? Well, they want us to find this sine of U minus V. The sine of U minus V is a difference, so that means we're going to be using the sine angle difference identity. If you don't need to flip to the notes to figure out what the formula you want to use is, or equation or identity, whatever you want to call it, then amazing. Go you. That's great. You've already memorized it. And if not, that's okay. You're working on it though, right? So I'm just color coordinating quickly. I'm sorry, you could skip ahead a little bit if you don't care for this, but I know some people like that. Okay. Oop. So in blue, ready? Sine of U minus V. I'm going to use the sine angle difference identity, swapping my alphas and betas for U's and V's. That's the sine of U, cosine V, minus cosine of U, sine V. This is what I'm looking for. I have to get this all from my pictures. Okay? Everything that's involved with sine of, well, not sine, everything involved with U, let's do this. Angle U is over here. And everything involved with V, angle V, it's not in that quadrant. I just drew it on that picture, and on this picture. So U stuff, orange, V stuff, green. So orange, orange, green, green, okay? So we're going to get answers when you find the sine or the cosine or the tangent, whatever, of an angle. Your answer is a ratio, proportion of two sides. Let's look at the sine of U. That was actually given to us right in the beginning of the problem. Could you pull it from there? Sure. This stuff really heavily relates to lessons 7 and 8. So again, if you have really good notes on that, that wouldn't be a bad idea to go back and look at that. So here I get negative 3 over 5. Cosine of V was also given right there. 12 over 13. Nice. Cosine of U. Okay, here's the orange picture. Cosine would be adjacent over hypotenuse. So that's going to be negative 4 over 5. telling you, the number of people that mess up the stuff with the positives and negatives, it's a lot. Don't be that guy or gal. Sin V, we're over here. Opposite over hypotenuse. So that is 5 over 13. Just watch your positives and negatives always. Now, next step. -3 times 12 is -36. I usually don't reduce here. I know I like to normally reduce before I multiply. However, right now they do have a common denominator, 5 times 13, whatever that is. We'll talk about that in a second. But if I reduce one of these and the other doesn't really reduce, although kind of should, well, not necessarily actually. So if it doesn't, then you can't combine them. So it's just better leave it be, okay? And minus negative times positive, so minus and negative, so this will become a plus, okay? 5 times 13, I always go over this in class, but anytime I multiply a number by 5, I multiply it by 10, and then I take that and I divide it by 2. That's the same as multiplying by 5, okay? You can do tricks like that with division as well. So it's 130, and then divided by 2, 65. And to me, it makes it a little easier. So my common denominator right here is 65. And I also have now, I took care of the two negatives, turned plus. 4 times 5 is 20. Now, last step. I'm going to bring it all together. Sine of u plus v, but the u plus v better be in parentheses. The sine of u plus v equals -36 plus 20. So I have more negative than positive when I'm combining these, so my answer should be negative 16 over 65. Now is when I would check if I could reduce. Doesn't look like I can though, so we are done. And that's the end of guided example 3. Your job is to remember when you see a problem like this again next time, that this is the way we do it. If there were shortcuts, I would have showed them to you. Don't make up your own. I majored in math. Maybe you haven't, right? So don't make up stuff, okay? And 2 more to go. I hope you're okay. If you need a timeout, maybe it's a halftime for you, intermission, you want to go get a snack, press pause, get yourself a snack. Go, give your dog a belly rub and come back, okay? Don't forget to come back. Here we go with guided example 4. And what we're doing here is we're going to simplify the expression. So simplify, it's no equal sign. So there's no equation. There's no number to fill in for x, so we're not evaluating. There's no equal sign with something else on the other side, so we're not verifying. There's no equal sign, so we can't solve. I mean, I think I said that, but that's everything, right? Now again, what unit are we in? What section? What lesson? We are doing angle sum and difference identities. I have a cosine and I have a minus sign. What's the identity? Cosine of alpha minus beta equals cosine alpha, cosine beta, plus sine alpha, sine beta. Alpha is x, beta is pi. Fill them in for everybody. Every alpha is x and every beta is pi. So we have cosine x, cosine pi, plus sine x times sine pi. But we're not done. Don't be a weenie. Don't be lazy. Cosine x and sine x are pretty much stuck, but where's pi? 0. Open up our angle. Round and round and round we go. One full revolution is 2 pi. So pi is 1/2 of a revolution. Half of the circle. It's pi radians, 180 degrees. What is the ordered pair over here? That helps us find sine and cosine, right? The xy is our cosine of our angle and then our sine of our angle. What's that ordered pair? That's the origin, 0, 0. Unit circle, the radius is 1 unit, so that's the radius, isn't it? Left 1, up or down 0. That means the cosine of pi is -1. We should know this. And if this is like, oh, really? I had no idea. Then you got to get with it, okay? Cosine of, nope, I did cosine already. Sine of pi then is 0. Why do we need that? Well, my friends, because it's in the problem, you silly geese. Where are we going to deal with that? So let's see. Cosine of x minus pi equals cosine of x, you stay, cosine of pi, -1, plus sine of x, you stay, times, maybe I'll put this in parentheses too so we don't get too confused. I don't want you to think it's subtraction, you know. Sine of pi, which is 0. A little bit more. Don't be sad. We got this. You should be proud. You're doing great. -1 times cosine x is negative cosine x. Lovely. Sine x times 0. Bye. See you never. We're done. We are done. Fun fact. If you graph y equals, ooh, that should be cosine. Cosine of x minus pi, that will take our cosine graph and move it to the right pi. There's pi. So that will move this guy right here. So now my new graph, something like this. I'm getting confused. Like that, right? Now, my scale might be off. Sorry, I just sketched. If I went back to the beginning, it would look like this. So here is the piece we would draw if we drew cosine of x minus pi. We would draw that. Let's do a little color action, shall we? Okay, this is gonna be helpful in a future example, but honors definitely be focused and listening. Academic level, you know, still totally worth it. Just listen, focus, soak it all in, but that right there is this. And we just simplified and said it's equal to that, right? So what does that look like over here? Negative cosine, the negative cosine graph goes like this, back to here. That is negative cosine. Y equals negative cosine x. So just let that marinate. Think about that, because we're going to have some stuff come up in the future that we might have to have a discussion about. Sorry it's a little smudgy, but let it stew, all right? Last one, guided example 5. We have not done any solving yet, so now we solve. We've evaluated, simplified, verified. I forget what else, but making moves, right? So we're going to solve this. Now, it's kind of hard to solve when you have a plus or a minus inside of your parentheses for the angle location. Like this is normally our angle. This is our angle, and we have like a sum or a difference in there. So to get rid of that, we're really just going to apply the sum, angle sum formula for sine, angle difference formula for sine, kind of open this all up, clean it up, similar to the last example where we were able to simplify a lot of things, and we're going to solve from there. Okay, so let's get going. Here we got a sum, sine of alpha plus beta. Don't get confused. I'm going to kind of skip a few steps this time. So it's going to be sine x cosine pi over 4 plus cosine x sine pi over 4. Those are my alphas and betas. Think about it, rewind, press pause, do what you got to do. +1 is +1 equals, same idea, minus, and they're in a different order, so alpha and beta are a bit switched. Sine of alpha cosine of beta minus cosine of alpha sine of beta. And the directions say to solve between 0 and 2 pi, basically. So we don't need a general solution. We just need to find the answers between 0 and 2 pi. Now, let's evaluate some parts of this. We're going to evaluate cosine of pi over 4, sine of pi over 4, sine of pi over 4, and cosine of pi over 4. All right? That's 45 degrees. That's exactly in the middle of quadrant 1. That's medium, medium. It's root 2 over 2. Both are positive. So I'm not going to put it on the right. I'm going to stick it in front as like a coefficient because I don't want you to mix it and blend it with the x at all. So I'm going to do root 2 over 2 sine x plus root 2 over 2 cosine x plus 1 equals root 2 over 2 cosine x minus root 2 over 2 sine x. Now, if you look closely, you should be able to see that we can either combine like terms you might see, or we can simplify, reduce, cancel. We can cancel something. So root 2 over 2 cosine x. If I tried to subtract it and combine it over here, what's going to happen? They're going to cancel out anyway. We have one on each side. So subtraction turning into 0, whatever, that's canceling. Those are gone. Okay? Adios, sayonara, see ya. Now here, though, if I add this over, it does not cancel out. I mean, on this side it does, but not on this side. That'll give me, okay, I have root 2 over 2 sine x plus root 2 over 2 sine x. Do you know what that adds to? Root 2 over 2 something plus another root 2 over 2 something. Careful, that's going to be 2 root 2 over 2 of that thing, sine x. But then these reduce down to a 1, so I'm really left with root 2 sine x. If that's a little confusing for you, another way to think of it is, I should have written plus root 2 over 2 sine x in front. Another way to think of it is you have half of root 2 sine x and another half of root 2 sine x, because when you divide by 2, you find half. And if you have half of something and half of it again, you have a whole amount of it. So we have a whole entire root 2 sine x. So we have sine x with the coefficient of root 2, okay? Plus 1 equals 0. So maybe I should have brought it to that side. Doesn't really matter. Root 2 times sine x times sine x plus 1 equals 0. Too many people regularly tell me to get rid of this root 2, we're going to subtract it. Stop doing that. It's attached by multiplication. It's root 2, that's the square root. I know my thing always blends in. Sine x is not under the square root. Make it clear. Do not get sloppy. I'm going to bring this plus 1 to the other side with subtraction, not by picking it up and putting it down, right? So that equals negative 1. Divide by root 2. Divide and divide. Some of you are going to be doing this in your head and you're going to be steps ahead. Good, amazing. If not, pay attention. Just picking up from here. So what am I left with? Sine x equals 1 over root 2 is the reciprocal of root 2. I know it's negative. We'll put the negative there as well. 1 over root 2 is the reciprocal of root 2. What is the reciprocal of root 2? You should have memorized that the reciprocal of root 2 is, we memorize those two, root 2 over 2. I know we derived where it comes from. We show how we get that answer, but you should just know that by heart. That means this, since that is the reciprocal, is equal to this after you rationalize. So it's negative root 2 over 2. So we're here right now. We are solving. This is trig inverse, whatever way you want to think of it, but the sine of what angle or angles between 0 and 2 pi give us negative root 2 over 2. Where between 0 and 2 pi are my y values down medium, 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 medium. What angles are those? When x equals 5 pi over 4, and don't use a plus sign, 7 pi over 4. Those are our answers. Okay, that is it. That is the end of guided example 5. What I think I might do is do a separate video perhaps with some advice for the memorizing a little bit later, because I feel like this was long enough. Very long, and I want you to try the homework examples, and we'll work on that memorizing and those strategies and techniques a little bit in the future. 5 guided examples. It was long, I know, I'm sorry, but important stuff. Bang it all out, kind of get it all together. If you had to press pause, that's fine, but I need you to know this stuff all goes together, and I don't want to break it over many videos, many days. They all go with the same lesson introduction, which was angle, sum, and differences, okay? So here on this next page are your homework examples, the ones that I want you to do on your own, and you can do them. They're numbered 1 through 5, and they align with the 1 through 5 guided examples. So if you have to go back and try, you're going to do that. After you turn these in, I will supply you with the answer key video to check and correct. Maybe I'll even do a separate video for each example so that I could kind of help you out one at a time, you know? This way I don't have to give you the entire answer video. I'll give you one at a time, okay? But work on coming up with your own strategies for memorizing those identities. Do your best. And, you know, I always have like my weird, funny tricks and stuff. And I actually have one that's relatively young. I learned it from one of my students who made it up a few years ago. And I thought it was just so clever. So I use it all the time now. But work on memorizing these guys, okay, from the intro to the lesson. And get these all copied to do on your own. Press pause because the video is going to end in a minute. If you are nervous to do the on your own examples, but you're going to do it anyway, even if they're wrong, you're going to do it, and you're going to do every question. You're going to turn something in. You're going to try your best. Put a thumbs up. If you're too scared because you don't want to be wrong and you're going to be a weenie, put a thumbs down. Don't be a weenie, okay? All right, so I will see you guys in the next video.